This is CIT 1121, Module 7, Submodule 3, MAC address table. Okay, MAC address table actually resides on a device called the switch, where the switch is the intermediary device. It's going to allow all of your host devices to communicate on the same LAN through the MAC addresses. So let's take a look at the next slide, which is just a little picture that I can draw into. And we've got a switch, and then we've got 4 little PCs that are going to talk to each other, and they're all in the same LAN because they're connected to the same switch. How do we find the edge of the LAN? We have to put in a router, but we don't have a router in this picture, so we'll just go with what we have here, okay? Now, here's the thing. The way a switch operates is as follows. The switch will create a table, and it's oftentimes called a CAM table, which stands for Content Addressable Memory Table, and that CAM table has two fields. One for interface and one for MAC address. Now, when they say interface, what we're talking about is the actual physical interfaces on the front of the switch. So if we looked at what a switch looks like from the front side, it kind of looks like this. And there's a bunch of little ports. And these are for RJ45 jacks. I know my drawings are not that good, but at least you get to watch something move on the screen, right? So this particular interface, that might be fast Ethernet 0/1. And this one would be fast Ethernet 0/2, and so on and so forth. And those interfaces create the left-hand column here. I'm just going to put in FA 0/1 for the first one. I'll do 2 and 3 and 4. And what they do is they populate with the source MAC address of the devices that are connected. So if we said, just to make life easy, that H1 is connected to interface 1, and H2 is connected to interface 2, and H3 is connected to interface 3, and H4 is connected to interface 4, then the switch would learn all of those MAC addresses. Now, here's the idea. If the switch learns the source MAC addresses of the devices, if another device wants to send to that device, the switch knows the MAC address and will read the destination value and forward it towards where it's at. So the switch actually learns and builds its table. How it's built is through the source MAC addresses, and how it works is it actually forwards towards the destination based on the sources that it learns. We'll get into that in just a second here. So if we said that, once again, that device 1's MAC address is all A's, 2 is all B's, 3 is all C's, and 4 is all D's, then these values would fall into this CAM table as such. A, B, C, D, D. And we're in good shape, right? So if A wanted to send something to B, that frame header of that traffic would look like this. The frame header has really 3 fields. There is the destination MAC address. There is the source MAC address. And there's another field called the type field, which identifies what the layer 3 value is going to be, so on and so forth. So in this case, if A wanted to send to B, the source MAC address would be A, and the destination MAC address would be B. And that's how the switch works. You send this into the switch reads the destination MAC address, forwards the traffic to the only device that has a MAC address of BB, and it's all good to go. If you unplugged H2 from port 2 and plugged it into port 6 on the switch, it would move the MAC address into the other device. And there's a reason for that. And the reason for that is something that's called gratuitous ARPing, which gets us into a very deep conversation about how things actually work. So we've said, okay, here's how the switch works. The switch takes its interfaces and associates with source MAC addresses. What we didn't teach you is, how do those source MAC addresses appear in the switch? And the answer is through the magic of gratuitous ARP. And I'm just going to go to another slide to show you this one. And I'm just going to write gratuitous ARP over here. Gratuitous ARP is what I'm going to show you. Okay, now here's the thing. We've seen this before. What a switch can do, or what a device can do, is leverage the information it has to learn more information about another device, or a switch can actually use the information it can gain from a device and fill in something like a CAM table automatically based on the device. Now, here's the thing. What gratuitous ARP says is this, is that if we have a device that's on the network, let's say it's 192.168.1.10 for our H1 device. And we can make H3, just because I have some space down here, 192.168.1.12, so on and so forth. Now, the first thing that happens under the rules of TCP/IP is this, is a device can participate on a network if it is a unique IP address. So, if device H1 wants to participate on the network, what it has to do is announce itself to all the other devices. It has to send out a message and say, hey, I'm 1.10, essentially, is what it says. If someone else is already 1.10, please send me a message back, and I won't join the network. If no one else responds back when I announce myself as 1.10, I know I can join the network, and then that's how that works. So, if you remember the broadcast ARPs from before, we had shown you broadcast ARP, and the gratuitous ARP is just it's just a version of the broadcast ARP request. So what H1 is going to do when it first joins the network, and when I say first joins the network, I mean someone takes a cable and plugs its network card into the switch. That network interface card goes into an up state. Electricity flows through that interface. The lights go on, and it tells TCP/IP, the TCP/IP component of the operating system, hey, this network card is up and functioning. Let's make sure that we're unique. That's the first thing we have to do. So the first thing that happens is H1 will send out a message, and it'll say, this is just like we did before, it'll say, who is 192.168.1.10, and the source MAC address will be, source MAC in the frame header is going to be the A's, and the destination MAC address in the frame header is going to be all F's, which means it's a broadcast message. So before H1 can even participate, it's going to send out this gratuitous ARP. It's going to hit the switch is going to see that it's a broadcast, and it's going to fire the broadcast to all three of these devices. Now, if H1, if H2 or H3 or H4 already has joined the network with 192.168.1.10, they would send a message back to H1 and say, I'm sorry, you can't participate. And at that point, H1 cannot participate on the network because it's been received a message that says, hey, you failed the first test. You have to have a unique IP address in order to join the network, and you failed. Another device said it has that IP, and then it's game over at that point, and that machine doesn't work, and then you get a help desk call or a ticket gets open, and someone says, I can't get on the network, and you got to figure out why. Easy enough, okay? Now, here's the thing. Let's suppose H1 passes that test. Fine, that's great. Here's the deal. H1 is plugged into interface FA0/1 on the switch, right? And what our switch is doing is it's going to learn MAC addresses. So as soon as that gratuitous ARP goes out and it hits the switch is going to look at that value and fill in its CAM table with that value. Pretty cool, huh? So every time a device, the first thing it does is it does a gratuitous ARP, and what a switch does is it leverages that source MAC address to that interface, and it writes it down and it builds that table. And then it can use this for forwarding. So then later, when H3 wants to send something to 192.168.1.10 or to device H1, H3 will learn the destination MAC address will be A's. It'll send it to the switch. The switch will read the destination MAC address field as A's, and it'll send information over to H1. And that is how a switch operates in basic networking. And it's really not any worse than that until we get to 1122 and we teach about VLANs and we start chopping up the ports into other pieces. But we don't need to talk about that today.